Hello, class 12th physics, chapter current electricity, important questions. Two conducting wires XY have same diameter across a battery carrying same current. Number density of free electron in X is twice that of in Y. Find ratio of drift velocity in X and Y. So first thing is that I through X is equal to I through Y. Now we know the formula I equal to V now, that is Vd drift velocity, and for X, so V drift velocity for X, E number density in X, and A. Same diameter, so area will also same. So I'm not putting the subscript for that. Now V D Y E N Y A. So from here we can say, okay, find ratio of drift velocity in X and Y. So actually V dx by V dy is required. So that will be, it is going here, so it will go there, ny upon nx. Now it is given that number density in X is twice that of in Y. So it means ny upon in X, it is twice that of Y, that is 2ny. So it will be 1 by 2, that is 1:2. When electron drift in a metal from lower to higher potential, does it mean that all free electrons are moving in same direction? Well. Macroscopically, its answer is yes, but microscopically, it isn't. Actually, what happens in actual practices, let us suppose uh, without an external voltage, if electron were randomly moving like this, then due to that electric field, they will experience a slight deflection and they would be just shifted, as I'm showing here, like this. You are not required to do all of it, but you can say that relative position of colliding electron shifts toward positive potential however not all the electrons are moving in same direction. So in order to simplify the concept of current, we generally say that electron is moving and then colliding, then again moving, then colliding. But actually what happens if it was colliding somewhere here in the region of my palm, then due to that external voltage, it will be shifted. Let us suppose this is positive end, it will shift it. And other electron will also shift, other electron will also shift. And then overall, that shift results to the formation of current. So just remember this question, that whatever we believe that electrons are being pushed and they are moving, but no, actually they take position of each other. Whatever vibrating here will be shifted toward positive potential for a small amount. So this process goes on and it constitutes current. All right, draw a graph between resistivity and temperature. Actually, they will not give these symbols. They will specifically say resistivity and temperature. I have just written the symbol in order to just avoid writing their names. For semiconductor, for copper or metal, whatever, they can also say silicon. So we know that silicon is semiconductor, copper is metal. So what is the basis of this question? How we are going to draw the graph? So remember one thing. Okay, this is for semiconductor and this is for copper, that is metal. So we know one thing, that in semiconductors, resistivity decreases with increase in temperature. So it will be an inverse proportion graph. So it will start from somewhere here, because there is some finite resistivity initially, and so with increase in temperature, it goes like this. And for metals, what happens? Resistivity increases with increase in temperature non-linearly. Actually, initially, it increases non-linearly, then it can increase a bit linearly. But actually, this relation is non-linear. Okay, next, explain why resistivity of semiconductor decrease while that of metal increase. We can explain it on two bases. And if specifically those two ways are asked, then you have to ask in that way. Otherwise, any of the way you can follow. Now, for semiconductor and for metals. So on the basis of temperature dependence, we can say that resistivity final is equal to resistivity initial 1 plus alpha, that is temperature coefficient of resistance, delta T. And for metals also, it is rho I 1 plus alpha delta T. So for semiconductors, alpha is negative, negative, and for metals, alpha is positive. That, this is the reason. In terms of temperature dependence, that formula, if we refer this formula of temperature dependence of resistivity, then we can say in semiconductors alpha is negative, that is why resistivity decreases with increase in temperature, and here in metals alpha is positive, so resistivity increases with increase in temperature. But if in terms of microscopic parameters it is asked, then we know that resistivity is m upon tau E square n, where terms are in their usual notations. I'm not going to express them. I'm just stating m is mass of electron, tau is relaxation time, E charge of an electron, n number density. So what happens in semiconductors, with increase in temperature, n increases. That is number of free electron per unit volume, or number density of free electron increases. So rho decreases. There is a disclaimer also. However, although tau decreases, actually what happens when temperature increases, tau decreases, n increases. Now there is a quest, whose decrease or whose increase is dominating. So actually tau decreases, but its decrease is dominated by increase in n. It means there are two things happening. Tau is decreasing, n is increasing, but it is dominating. Increase in n is dominating here. That is why resistivity decreases. Now just opposite here. Rho equal to once again m upon tau E square n. Now with increase in temperature, tau decreases and therefore rho increases. Although n increases, but its increase is dominated by decrease in tau. So what is happening here? Actually in metals there are already free electrons, so chances of a new free electron is very less, and their contribution is also negligible in comparison to decrease in tau. So just single way, and you can if you memorize this, you can easily answer this part. Two wires equal length, one of copper, other of manganese, have same resistance. Actually we know that resistivity of manganese is greater than resistivity of copper. Okay, now what they are saying, two wire equal length. Okay, all right, so which wire is thicker? So what we are going to do is they have same resistance, so resistance for manganese is equal to resistance for copper wire. And now we are going to do that thing, that formula, rho L upon A. I'm writing it here. Rho of manganese, I'm just writing M. L equal length, so I'm just writing L. And A, we have to find which one is thicker. So here I am writing AM, and that is equal to rho for copper, length is same, upon A for copper. L will get cancelled. And now see what is going here. If I cross multiply, actually I'll get cancelled. I don't cut here. Just in mind we can cut, otherwise it look messy. So it will be rho for manganese upon rho for copper. That is equal to area of cross section for manganese upon area of cross section for copper. And we know that since manganese, resistivity of manganese is greater than resistivity of copper, it means rho m upon rho of copper is greater than 1. Therefore area for manganese upon area for copper is greater than 1. Therefore area for manganese is greater than area for copper, so manganese is thicker. Same question can be asked, which one is longer? If both are given of same area of cross section, you will proceed this way. All right, next question. It is based upon Kirchoff's law. So we can, all right, when I apply Kirchoff law, I have my own methods to solve it. So if you have watched my videos and you follow my ways to solve it, then only uh, do it with my method. Otherwise, apply your own methods and see if answer is same, processing is almost same. So what I do, sigma E equal to sigma IR. And what is sigma E? So what I am doing, I am taking this way observation. So I am, this is my method. While finding the algebraic sum of EMF, what I used to do, the plate from which you are leaving, we are going like this, and the plate from which you are leaving, take the sign of that plate. So it is positive 200. And now here, and now we are exiting from here. So minus 10, that is equal to IR, I into 38. So it will be 190 and upon 38 equal to I. You can calculate it of your own. Write the relation between V in terms of E, I and R. So here it is V equal to E minus IR. How come? Actually, we know that E equal to I, R plus R. And then it will be IR plus IR, and second IR means V. Define resistivity, conductivity. Okay, so I'm doing this. So resistivity. First, I'm going to write its formula. Ra upon L, rho equal to Ra upon L, remember. So how we can define it? That resistivity of the, you have to write entire, I'm just being a bit lazy to write it. Resistivity of the material of a conductor of a body is much better word, is equal to resistance offered by its unit area of cross section and unit length. And for conductivity, it is 1 upon rho. The reciprocal of resistivity is called conductivity. So, okay, once again, actually, if we take A as 1 unit and L as 1 unit, then rho is equal to R. So, resistivity is that resistance which is offered by the unit area of cross section and unit length of that body. Next, and of course, it is the property of material. Next, define drift velocity. So, there are different definitions for it, but if you see my video on it, I have defined it in that way by which you can derive its formula also. So, it is the average final velocity gained by free electron of a conductor when potential difference, when potential difference is applied across its ends. That's all. Okay, write its relation with current. So we have done it earlier. Vina, D silent. How does how does random motion of free electron affected when potential difference applied? So I have answered it earlier, but we can say that it is shifted toward positive potential. Means that random motion is shifted towards. So we can say, like, if it was colliding, it was moving like this, I have formed a star formation so that it look more easy to reproduce. So this is how we can draw it, a shifting. Oh, and that's true. If this end is positive, this end is negative, then only. So here another one, draw VI graph for gallium arsenide semiconductor. It looks like it is the question related to that semiconductor topic. indicate ohmic region and negative resistance region. So this is completely your observational skill or memorization technique is required here. So I'm drawing I here and V here. So yeah, sometimes this part is questioned that VI or IV, what is the difference? So there's not much differences. So you can draw any of as per your convenience. So this graph goes like this. So here I'm dividing this graph into few parts, A, B, C, in fact C, D, and then E. So ohmic region, actually this AB is ohmic region, and CD is negative resistance region. Okay, another question which resembles with this. Draw VI graph for gallium arsenide solar cell. So there is a difference. It is just the component. This is just the material, gallium arsenide, and this is a device which is a PN type thing. So here both are not same. There will be some difference. It is like this. I have included this question here. It is totally based upon that chapter, semiconductors. So but I have drawn it here because in some books this question is asked and this graph is drawn. So not to be get confused, if gallium arsenide semiconductor is asked there, it doesn't mean they are talking about some kind of PN diode or solar cell and you have to draw this. No, at that time it is just a semiconductor, maybe P type, maybe N type, maybe intrinsic. So at that time, this is the graph. Remember this thing. And until or unless they draw it for solar cell or gallium arsenide diode or gallium arsenide solar cell, you need not to draw anything else. So here V, here I, so it goes on negative side. So indicate open circuit voltage. So this is open circuit voltage, V open circuit. And this is short circuit current. You have to write it in full. I'm just giving it symbols only. IV graph for metallic wire at two different temperature T1, T2 is as shown. Okay. This is the same wire, but operated at different temperatures. Now, step by step, we will proceed step by step. For I versus V graph, R is inversely proportional to slope. How come? Because for IV graph, this is I, this is V. If you find its slope, it will be delta I and it will be delta V. And what is slope? It is perpendicular upon base. This is perpendicular, this is base. We know that V upon I is resistance. So I upon V is 1 upon resistance. That is why they are vice versa. Not all the slopes, but I versus V graph slope is, so R is inversely proportional to slope. It means now slope of 2 is less than slope of 1. So this implies that resistance of 2 is greater than resistance of 1. Now the question is, which one of 2 has temperature is lower? So we can say in metals, R increases with increase in T. So T2 is greater than T1. So T1 is lower. Nichrome and copper wire of same length, same radius are connected in series. It means both will draw same current. Current I is passed through them. Then which wire gets heated up more? Justify. So we know that both are having same length and same radius. So we know since resistivity of nichrome is greater than resistivity of copper, and now resistance for nichrome will be equal to rho for nichrome L upon A, and resistance for copper is rho copper L upon A. Length and area of cross section are same because radius is same, so area is same. It means that now since resistivity of nichrome is greater than copper, so resistance of nichrome is greater than resistance of copper. Now again, heat energy is equal to I square RT. So in the given time, as I is same in series, So heat in nichrome will be greater than heat in copper, as resistance of nichrome is greater than resistance of copper. Simply we can do it here, or more mathematically you can do it like this: heat in nichrome upon heat in copper is equal to resistance of nichrome upon resistance of copper, and which is greater than 1. From here we can say, so heat in nichrome is greater than heat in copper. We can also do it like this. Okay, draw a graph showing variation of resistivity with T. I don't know why I have written this question, because it is incomplete question, so I am skipping it. Find drift velocity in a wire area of cross section this, carrying current, having number density this much. Okay, so it's a very easy question, direct question. I don't know these two questions how I have mentioned here. Anyway, NEAVD, or to memorize, memorization technique says VNA. I equal to VNA. So I is 1.8, VD we have to find, E we know 1.6 into 10 to the power minus 19. N is given, so there is nothing, no worry about this question, because everything is given in fair way. Neither we have to change anything, or okay, some rearrangements here, then I will bring them here. So it will be 10 to the power 9, and if we multiply both of them, 4, it will give 4, and 4 nines are 36. So it is 36 into, oh my god, this is also there. So this is 2100, 10 to the power 2 VD. So finally VD is equal to 1.8 upon 36 into 10 to the power 2, which is equal to 0.05 into 10 to the power 2, and that is 5 into 10 to the power minus 4 meter per second. And all right, just memorize its order. Sometime direct question can be asked, what is its order? So 10 to the power minus 4 is its order. Charge flow through a conductor varies with the time as q equal to 0.5 t square 2t plus 5 coulomb. Find I at t equal to, actually it is a varying current, so at t equal to 10 second they have asked. So we know that I equal to dq by dt. Here you can understand why we use that differentiation term. Sometime q upon t, sometime delta q upon delta t, but this time dq upon dt. So it is a simple differentiation type question. So I will just this question will just recall our understanding about differentiation. So differentiation of this 0.5, differentiation of t square is power in front and 1 power minus, so t to the power 1. Now 2 is taken out, differentiation of t is 1, so 2 into 1, and 5 is constant term, so 0 differentiation 0. So it will be t only, t plus 2 ampere, and at t equal to 10 second, so it was more like a mathematical question. 10 plus 2, that is 12 ampere. A wire is stretched to double its length. By what factor its resistivity, resistance change? Resistivity remains same. This is the first part. Resistivity will remain same because material is same. Resistance, so resistance changes by this formula, where n is equal to folds, that is double here, so 2. So R nu is equal to 2 to the power 2 R, that is 4R. So it will change by the factor of 4. That's the answer. So remember that how this has come. Maybe I have a subsequent question. Yeah, there is. Here I can explain. So a wire is folded over itself. So if a wire is folded over itself, like I will use my mask string and folded over itself, so its area will doubled and its length will halved. So once again, that is the same thing will be used here. So R nu is equal to n square R, where n is fold, but this time this fold is 1 by 2 because it is halved, its length will be halved. So R nu is equal to 1 by 2 square R, that is R by 4. In hydrogen atom, electron makes this rotation per second around nucleus in an orbit of radius this much. Equivalent current is, so I equal to, we know, q upon t, and in terms of hydrogen atom this will be, q will be E, and time will be the time period, and we know that all right, so we have to do something with this. So here this rotation per second is actually frequency, and we know 1 upon t is 1 upon t is frequency, so e nu will be the current. So 1.6 into 10 to the power minus 19 multiplied by 6.6 into 10 to the power 15, and that's all. So I hope you can calculate it of your own. A wire of resistance equal to R, actually once again laziness, elongated n-fold, find new resistance. So let me tell you the entire process how this question can be proceed. Actually we have a tool that new resistance is n square R, but here actually its working is asked. So see, R equal to rho L upon A, we know about it. Next thing, if now what is happening, nu n, I'm writing Ln, is equal to n times L. It is stretched now, so its area will be contracted. So now what will happen, since Al, volume will remain same, resistivity and volume will remain same. So Al is equal to An Ln, which is Al equal to An and n times L, that is An equal to A by n. Now we can put it in our new, rho will remain same, Ln is Nl upon A upon L, that n will appear in the numerator, so it will be rho n square L by A, n square and rho L upon A is R. So this is how that formula comes. Okay, reasoning based question. Resistivity of copper is greater than silver. Still copper is used and preferred over silver. Why? The simplest answer is silver is costly. Costly. Or I can say costlier than copper. All right, next, that's sufficient reason. Next, resistivity, and one more thing, copper is more abundant than silver. Resistivity of aluminium is greater than copper. Now, another contrast to this, another question came. Still, aluminium is used to make electricity distribution cables or overhead high tension cables. Why? Now, the reason is aluminium is lighter than copper as its density is lesser than that of, less than is I think correct, that of copper. So remember these two contrasts. Silver is the best conductor, but it is costlier, therefore copper is used, and aluminium has greater resistivity, yet it is used for overhead cables because it is lighter, because it is less denser. Next, find potential difference across AB. So to do this, first we have to find current in the circuit. So once again, Kirchoff's law, I am going this way. So coming out from, okay, sigma E equal to sigma IR, coming out from this plate, so 6, coming out from this plate, minus 4 is equal to, current is I, and I am directly adding both of them, so 10I. So I will be equal to 2 by 10, this is 0.2 ampere, and now we have to find potential difference across AB. So AB will look like this. Current will go this way, this is I, and its internal resistance we have to show that also, 8 ohm. So let us suppose this is A, we know that this is 8, this is B. Now this is the second part of that question, or main part of that question. So what will we do? We'll complete this circuit, and once again I'm going this way. So there is a source of 4 volt coming out from positive plate, so 4 is equal to, okay, I have to write for figure 2, this is figure 1, this is figure 2, otherwise there will be a confusion that which part I am taking. Now I am going opposite to the direction of current, so minus 8I and plus VBA. So I is minus 8 into 0.2 plus VBA, that will be 1.6. 1.6 will appear here, so 4 plus 1.6 equal to VBA, and that is VBA equal to 5.6. but they have asked for VAB. See, actually VBA means VB minus VA, so that must be different from VAB, so that will be minus 5.6 volt.